Okay, today we discuss chapter 3, Gravitation. Look at paper 1. Number 1. Which statement is correct about Earth's gravitational force? Okay, we discuss about universal law of gravitation. So you read through all the answers here. The most accurate one is the Earth's gravitational force causes object to fall with acceleration that is inversely proportional to the square of their distances from the center of the Earth. We have the formula F equals G mm divided by R squared. Okay. Okay, number 2. Which graph shows correct relationship between gravitational force F on a point mass at distance R from the point mass? Okay, the formula just now, F equals to G mm divided by R squared, meaning 1 over R squared. Okay, so F and R squared is inversely proportional to each other. So number 2 answer is D. Okay, number 3. A satellite on Earth's surface experiences gravitational force W. What is gravitational force when satellite is placed into the orbit at height 3r, where r is the radius of the Earth? Okay. So F equals to G mm over R is equals to W. Okay. F2 G mm over 3r is height. Height. So the total distance between the two centers of the object. So we have r plus 3r squared. Okay. And then this one equals to G mm over 4r squared. That is equals to 1 over 16 G mm over r squared. Okay. See from here. Okay. It's W. Okay. So F2 equals to 1 over 16 times W. Okay. Or we get the answer is A. Okay. Okay, number 4. A meteorite falls freely towards the center of spherical planet. This is number 3. Okay, number 4. When it reaches the surface of planet, its acceleration is g0. What was its acceleration at a height r above the surface of planet? Okay. So this is g equals to gm over r squared. Okay, continue revision part 2. Next part 2. So this one. Okay, use the formula of gravity to solve this one. This one at the surface of the Earth is G0. Okay, so from here we get Gm equals to G naught R squared. And then what was acceleration at height r above the surface of planet? So we have G, the new one is Gm over r plus r is 2r squared. So we have 1 over 4 G, sorry, capital G, should be G over Gm over r squared. Okay, so this one is equals to G naught here. Okay, so Go 1 over 4 times Go B. Answer is for number 4. Number 4, answer is B. Okay, number 5. A tunnel dug from a point P to another point R at equator through the center Q of the Earth. Assume the Earth has shape of sphere, uniform density, which graphs show correctly variation of magnitude gravitational acceleration with distance r from P to R. P to R. So at the center here, G equals to 0. Okay, so G will increase until maximum at point R or point P. So normally at the surface of the Earth is 9.81. Here also is 9.81. Okay, so from P to Q, the gravitational acceleration decreases, becomes 0, and then increases again, become 9.81. So the best graph described from P to Q and then R, okay, is B. Number 6, figure 6 shows tennis ball tied to a string is swung at a constant speed in a horizontal circle. Which statement correct about movement of the ball in figure 6? It's like circular motion. The ball is moving at constant velocity. Wrong, because direction keep changing. The force acting on the ball changes continuously. No. Period of revolution also does not change. So acceleration of the ball directed towards the center. So this one is centripetal acceleration. The answer is D. Okay, number 7, a stone tied to a string being swung in vertical circle. Which direction A, B, C, D will the stone move if the string release? This one is vertical, so it will follow the tangent of the motion, tangent to the point. Okay, from here we can see number 7. 7 is A, A direction. Here. So move in tangent, straight line. Okay. Okay, number 8. A planet of mass m move around the sun with a period t in circular orbit of radius r. Which of the following equation for the mass of sun? So for the mass of sun, you can use the formula G over r squared, meaning the gravitational force equals to centripetal force, mv squared over r. Okay, v is the orbital speed equals to m 2 pi r divided by t. Okay, distance traveled by one complete revolution is one complete circle, and then the time taken is period of revolution, so or the orbital period divided by r. Here got squared, yeah? And then we have g over r squared equals to m, so you can just open the brackets. We have 4 pi square r squared divided by r t squared. Simplify. Okay, so you will get is gm equals to 4 pi square r cubed over t squared. Then m equals to 4 pi squared r cubed divided by gt squared. Okay, so you get this one. Answer is D. Okay. Okay, number 9. This is number 8. 8. Number 9. What does the moon? Why does the moon stay in its orbit at constant distance from the Earth? Okay, the Earth's gravitational pull on the moon provides centripetal force that keeps the moon moving in circular orbit around the Earth. Okay. Gravitational force F G over r squared equals to the centripetal force mv squared over r. Okay. Okay, number 10. A planet of mass m has moon of mass m, small m, moving in circular orbit of radius r around the planet. Given the universal gravitational constant g, the linear speed v of the moon is... So this one also we use the same relationship. mv squared over r equals to g over r squared. Okay, so the small m cancel. So have v squared equals to gm over r. Thus v equals to square root of gm over r. So this is the linear speed or orbital speed. Okay, so answer is C. Sorry, B. Capital M, not small m. Okay, small m cancel already. Because the one that orbit is the small m, so this is the small m, this is the small m, the one that orbit. Okay, the capital M is the focus planet. Okay, number 11. 2 moons were found to be orbiting around the planet Jupiter with the same period. Which physical quantity is the same for both moons? Same period means they are in the same orbit. Okay, so same orbit means same radius of orbit. Okay, number 12. Number 12, satellite J has twice mass of satellite K and revolve in the same orbit as K. The linear speed of K is, remember there's a point, same orbit, so meaning they have same linear speed. Okay. Number 13, which graph shows correct relationship between linear speed and radius for the satellite of the orbit around the Earth? So V equals to square root of gm over r. Okay, so V squared, okay, directly proportional to r, 1 over r, okay, or V squared inversely proportional to r. So the answer 13 for number 13 is A. Okay, number 14. Figure 14 show 4 position of a planet revolving in elliptical orbit around the Sun. Which position A, B, C, D is the planet moving at the lowest orbital speed? Lowest orbital speed means V equals to square root of gm over r. If V is the lowest means r is the furthest. Okay, so which one is the furthest? Is B, boy. This one. Okay, number 15. The orbital speed of the comet in its orbit. Okay. Okay, this one because of the focus is Sun. Close to the Sun, the orbital speed increases. Further from the Sun, the speed will decrease. The meaning increases when it nears the Sun. Okay, number 16. Which statement is incorrect about characteristic of geostationary satellite? So you must be able to state the characteristic of geostationary satellite. So it always above the surface. Yes. Okay. Orbital period same as Earth, 24. Okay. And then it orbits above the equator. It revolves in an elliptical orbit around the Earth. So the answer is this one. Because the orbit is a circle, we assume as the circle. Okay. Okay, number 17. Which statement is correct about Kepler's second law? Kepler's second is about the sequence of the orbit. Okay. A line drawn from a planet to the Sun sweeps over equal areas in equal time interval. This one just need to memorize all the law. Okay, Kepler's first law, Kepler's second law, Kepler's third law. Okay, number 18. The ring of Saturn are made of rocky particle, radius r around the planet. The orbital period t of the rocky particle is directly proportional to Rn. What is the value of n? Okay, this one coming from the Kepler's third law. Okay, relationship between t squared and r squared, r cubed, sorry. T squared directly proportional to cube of radius. Okay, so you have from here t square root of r3, or t directly proportional to r3 to the power half, r3 over 2. So meaning n equals to 3/2. Okay, Kepler's third law. Let's see. Number 19, distance of the Earth from the Sun is L. Asteroid orbits the Sun 1/3 of a year. What is the distance of the asteroid from the Sun? So this one is relationship between the Kepler's law. So number 19. So you can put as Earth and Sun. So for Earth, Sun, I just put this one is square. So equals to R of Earth cube, R of Sun cube. Okay. Earth from Sun is L. Asteroid. Sorry, not Sun. Asteroid. Asteroid A. Okay. So Earth orbit the Sun. So the period is 1 year. Okay, so 1. Okay. For the asteroid is 1/3 of 1 year. And then R for the Earth is L cube divided by R A cube. Or we can write this way. 3/2 equals to L over R. Sorry. R A cube. Okay. So L over R A asteroid 9 power 1/3. Okay. So asteroid equals to L divided by 9/3. That is equals to number 19. The answer is 0.48 L. Okay, so Kepler's law. Number 20, the distance of planet from Sun is 9.6 times distance Earth from the Sun. What is orbital period of the planet in years? Okay. Same thing, this one we have the Kepler's law, T1 over T2 squared R1 over R2 cube. Okay. So if this one is for the planet and Earth, so you can put as this one as planet, this one for Earth, planet, Earth. Okay. So for the planet, we want to find, for Earth is 1 year. Okay. So RP distance for the planet is 9.6 distance Earth from Sun. Okay, cancel. So period square TP square equals to 9.6. TP equals to 9.6 over 2. Okay, so we get 29.74. Okay, number 21. Spacecraft of mass m projected vertically from the Earth's surface at the launching point. The gravitational acceleration g and radius of the Earth is r. To escape from the gravitational field of the Earth, the minimum speed of the spacecraft is okay. This one is for number 21. We have escape velocity. The formula is 2 gm over r. At launching point, meaning at the surface of the Earth, over r, radius of the Earth, equals to g. Okay, so to escape from the gravitational of the Earth, the minimum speed of the spacecraft is equals to what? So from here we can open the bracket, so we get is 2 gm equals to, sorry, okay, mg equals to g over r squared. Okay, small m cancel, so we get gm equals to gr squared. Okay, and then from the v equals to square root of 2 gm over r, so you substitute gm, so 2 gr squared over r. Okay, then can be simplified, so v equals to square root of 2 gr. Okay, so answer is C. Okay, gravitational force or weight of the spacecraft equals to gravitational force between the spacecraft and the Earth's surface. Okay, so we get this one, the answer. 21. Okay, number 22. Okay, number 22, a space moving near the planet of mass m. The shortest distance between the probe and the planet r. Okay, so v nearest one is 1.5 times gm over r. So the orbital speed at certain orbit is gm divided by r. Okay, now it's 1.5 times bigger, 22. Okay, so g is universal gravitational constant. So which diagram shows correct path of the probe? Because of the orbital speed is too high. So in order to reduce it to become gm over r, to reduce v, meaning need to increase r. Okay, to increase r means the probe need to drop to the further orbits, needs to drop down away from the planet. So the direction of the probe that drop down is better described by A. So it will drop to the further orbit, okay, with a certain orbital speed, which is cause it to orbit stably in the orbits. Okay, so ini terlalu tinggi, so it will drop to gm over r. So to produce gm over r means the value of r need to increase, so it will drop down to further orbit. Okay, that's all for part 1, section A.